And welcome to our weekly Waterjet Webinar series. This is week 5 of our 8-week series. So today we're going to cover Waterjets being a complementary technology for your already existing shop, and kind of just touch on how that could fit in and help you out depending obviously on what you're doing. We'll touch on a few other different bits and pieces, a few different industries, and take you through those. Okay. Let's get on to the first slide. Bear with me a second. There we go. So what we're going to touch on then, like I said, is about Waterjet's being a complementary technology. First of all, I'll just take you through a quick recap over how does it work and how will it fit into your existing business. We'll go through after that. Okay, first of all, how does it work? So remember, waterjet cutting is a high-speed erosion process. It's not actually a cutting process. It's just metal removal rather than actually shearing pieces of metal off. So it's not a standard regular cutting process. Like I said, high-speed erosion. So what happens is the water gets accelerated up to about twice the speed of sound as it passes through the orifice within the nozzle. This then creates a vacuum in the nozzle, which collects the abrasive particles, mixes them in, and then concentrates them down into a very tight jet of water, normally about 0.7 of a mil in diameter, which then obviously erodes the material away underneath it very, very quickly. You can see here a little example of what it looks like when it's actually cutting. And you can see the jet is working its way through material, bends slightly backwards. And it's all about how you control that bend, which determines how well your machine is going to cut. Basically, it's all about how you control it. It's not as easy as just firing water and abrasive through the material. To be able to achieve high accuracies, good quality surface finishes, and accurate geometry on your part, you need to be able to control that jet effectively. So the actual trick is in controlling the movement of the jet. So with our AEST systems, there is a very advanced cutting model working in the background, which figures out what accelerations and decelerations it needs, how it needs to behave around corners. We have such thing as corner parting, which is automatically programmed into the software, which will speed up any 90-degree corners, which is they can normally be quite slow, especially on thicker materials. This speeds them up so you get a much faster, better, cleaner, crisper edge. So that feed rate, so that the cutting model, is constantly adjusting that feed rate to make sure that the geometry you get and the surface finish you've asked for in your tool path is what you actually see on your finished part. It's quite important to understand, the extent of what's going on in the background, so you understand how advanced the AEST technology is in achieving the results that you're looking for with minimal input from the operator. That's one of the real key features about the AEST system, is for very little input, you get maximum output. You can go from a simple DXF file to a finish, or starting to cut your finished part in a matter of minutes, like 1-2 minutes maximum, and it's there and it's cutting. And that you can't really do that with any other technology. So the other thing the cutter model does is not only understand your geometry and how to control the jet, it also understands how different materials behave in different ways too. So, when you're cutting an aluminium, that's going to behave differently to if you're cutting nylon. So the cutting model looks at the material details that you put in there, and it also adjusts the feed rate and the behavior of the jet within the corners and the tight turns and the holes and the piercing, for example, to ensure that you actually get the part you're looking for. It's, like I said, it's quite a complex piece of software in the background, but as far as you're concerned as the end user, it couldn't be any simpler. Okay, so just a brief example here of the kind of parts you can do. This piece in the top left-hand corner here, this is actually a 2-inch thick stainless steel part. As you can see, it's square to round. That's been cut using the 5-axis system. You can see the quality of the surface finish inside there is pretty outstanding. You're not going to get that kind of surface finish with this kind of capability anywhere else. As you can see on this big thick part here, this is 262 mil thick, excuse me. 262mm thick aluminium. And not only have we cut that part, we've also etched this pattern in the top as well. So that's a question I get asked quite a lot is, can you etch with a Waterjet? Yes, you can. Is it what it's designed to do? No. Can it do it? Yes, it can. But, you know, there's obviously limitations around that because that's not what it's designed to do. It's just kind of a nice side feature that it can do. But as you can see, 262mm thick aluminium, and you can, again, see the quality of the surface finish on that part there. Top right-hand corner, this is actually a man-made porcelain. It's a stone product called Decton. And as you can see there, we've actually managed to cut a 9-sided shape out of it, which is pretty outstanding. And that was all done, like I said, one pass, one tool path from the 5-axis part. Then as you come down, you can see we do thick parts. This is the corner passing I was referring to earlier. Again, this is really good for tool and die industry, really accurate. We have systems that allow you to get a perfectly straight edge, so no taper. That's all done by controlling the angle of the jet. Also do really fine work as well. This part here is actually no bigger than a 50-cent piece. But as you can see, you can get really, really fine detail with that. And all these, by the way, are done with the same setup, the same nozzles, the same machines, the same software. There's nothing special going on here. If you can do this, you can do this. If you can, let's say, you can do the stone part, you can do the rotary part. And lastly, that's what this is. This is a part that's been machined using a rotary axis. So it's also been done with a combination of the 5-axis system, hence you have the countersinks. But this is done on a rotary axis, so the tube is mounted in the rotary axis and that turns instead of activating the Y-axis. So then your X-axis goes front to back while that turns underneath it. Incredible piece of software, very powerful. And it opens up what you can do with your Waterjet to many, many applications. Okay, so I think I've recapped now on what you can achieve with your Waterjet. Hopefully now if you're looking at it from your business point of view, you start to think, oh, hang on, maybe, what if? Okay, so let's try and go break those industries down a little bit more and get a bit more specific as to what it will do for you within your business. Firstly, let's look at sheet metal. Okay, so where would you use a Waterjet in a sheet metal shop? So traditionally, your sheet metal shop is going to be using lasers, turret punches, that kind of technology. Now, they're great. They're very, very fast, awesome if you're doing a lot of work, if you're doing a high quantity of parts, repetitive work, thin gauge materials. What the Waterjet can bring to that kind of business is the ability to produce a low quantity of parts really quickly, because the setup time required and the systems required to achieve those low quantities are very, very low. So the time is quick. You can have like 2 or 3 parts done and cut before your laser system's even warmed up, long before you sort your tooling out in your turret punch. You'll have those few parts done and dusted and sat on your bench ready to go. That can shorten the lead times down on tricky low quantity items as well. So whereas before you've got to wait until you can nest a sheet and fill a sheet with parts from other jobs to make it justifiable to do it on your laser or your turret punch, now with the Waterjet, you'll be able to get those few parts done and dusted and get the skeleton back in the rack and have the parts ready to go. Other advantage, it opens you up to be able to do thicker materials. Obviously with a turret punch, you don't want to go too much above 3 mil. With your laser, these days obviously you can get a lot thicker with your laser, but still anything above the 12 to 16 mil range is kind of getting towards the edge of what you can do. With the Waterjet, you can do 100, 200 mil if you want to, no problem at all. So if you're getting those jobs coming through that are slightly thicker that you're having to send out to somebody else to do for you, you can take care of those as well. Another advantage, you can do absolutely any material. Obviously with your standard sheet metal technology, especially laser, you're quite restricted to the materials you can do. Stainless steel, mild steel, some aluminium, depending on the type of laser you have. Whereas your Waterjet can do absolutely anything. I know I keep banging on about this one, but it's true. It just can. It can do glass, it can do ceramics, it can do plastics, rubbers, foam, every metal you can think of. All right, it will literally do anything. Another advantage, there's no heat affected zones because, as I explained before in the previous slides, it's a cold cutting process. It's just eroding the material away. It's not actually removing anything. It's not actually tearing anything. It's not putting heat into the system. It's a cold cutting process. So you have completely unaffected material right on there on the cut edge. You can get a tighter nest as well because you're not putting that heat into the material. You're not going to cause blowouts if you get your parts too close together. So you can have your parts right up next to each other with literally just a wafer thin 1mm piece of material between them. And they'll still hold perfectly well and still be able to do those really complex edges. And you can do really small parts, really small holes as well in thick material. I mean, in your 100mm thick, you could put a 3mm hole in if you so desire. So it just really opens up your capabilities of what you can do. Another advantage, if you're looking at it from a sheet metal point of view, is you can stack cut. Now, what stack cutting is the ability to do more than one thickness of material at a time. So you could literally take, let's say, 5 1mm sheets, put them all on the Waterjet at the same time, and cut 5 parts at once because you're cutting through all 5 sheets. As far as the Waterjet's concerned, that's just one solid piece of material, and it will just go all the way through and carry on going. So that can actually really increase the throughput and the efficiencies of your Waterjet if you wanted to do some slightly higher quantities. So as you can see, for your sheet metal, we're not trying to replace lasers. We're not trying to replace turret punchers. They have their place and they are fantastic at it. What we are trying to do is trying to open up your sheet metal business to be able to do more things, not be restricted by what the other technology can do. Okay, so let's move on to the next business. So the next technology we're looking at is your standard CNC shop. Now, where are you going to use your Waterjet in a CNC shop? So we generally look at using it for billet preparation. So if your billet's coming in and you're going to spend a lot of time on your CNC, making chips, making swarf, trying to get that down to a near net shape that you can then do your finished machining on, well, that's what you can use the Waterjet for. Okay, the Waterjet will get through that near net shape a lot faster than your CNC will, and it will then also free your CNC up to do the more accurate work, to allow it to concentrate on what it was actually designed to do. And the Waterjet can do all the legwork, the heavy lifting for you, and just get those near net shapes knocked out. You'll find you'll start to get a better yield out of your material. Therefore, you're going to save money. You're going to have less scrappage, less wastage, and you're going to decrease your lead times because you've got the Waterjet working there doing the heavy work while your CNC stuff is finishing everything off. It allows you to also get a, like I say, much tighter nest and do more complex parts as well, to basically, again, just make the whole CNC process a lot faster. So again, we're not trying to replace CNCs. We're just trying to make the whole process more efficient and quicker. Okay, let's move on to the last one. So the last one is your general fabrication shop. So with fabrication, a lot of the time people have got plasma cutters, or they have to go and send it out to somebody else, or they'll grind it out by hand using a hand grinder. So what the Waterjet is going to bring to that environment is the ability to produce shapes repeatably and accurately. So rather than your parts being kind of a bit haphazard as you try to do it by hand, you can now do it with a Waterjet and get them exactly the same every time, which is then going to make your following processes, your welding, your marking, your assembly, all that kind of stuff go a lot smoother and a lot faster because you know the parts are going to be right. So again, it can do any material. So as with your plasma, you're restricted to your mild steel, but a stainless. Waterjet can do anything. Again, thickness-wise, it can do any thickness. Another restriction with the plasma is the size of hole, the size of feature you can put into the thickness of that material. Well, with a Waterjet, it doesn't matter how thick it is. You can get a really tight hole, a really complex finished part from that thick material. It really doesn't matter. Again, no heat affected zones that you get with the plasmas. There's no post-op required. A lot of time with the plasma system, you've got quite a nasty burr on that breakout edge. But again, the Waterjet, you don't have that. It's a completely clean cut. You can work on it straight away. You don't need to grind that hardened edge away to get down to some good materials we had to weld onto. It's right there at the edge of the part because you've not affected the properties of the material in any way. Again, you're going to have minimal taper compared to a plasma on a water jet. And if you want, and you want to spec your machine up such, you can actually have it so you've got no taper at all. So that edge is completely square. So as you can see, no matter what your application is, no matter what your current business and your current technology are, a water jet can fit in somewhere, and it can actually help your existing technology. It can help it concentrate on what it's supposed to do and help you make the most out of that technology and make the most out of your business and your capabilities. Okay, so that was the last slide for today. We'll keep, like I said, we try and keep these to around about the 15-minute mark. I think we're pretty close on that this week. So if you have any questions, please feel free to post them onto the format where we publish these little short videos. And we will do our best to get back to you. If you want to email me directly, you can do. It's mattheww@headland.com.au, or you can call me on my phone, which is 0427 462 678, and I'll do my best to answer any questions you may have. Okay, well, thank you very much for your time. Thank you very much for watching, and hopefully I will be speaking to some of you soon. Thanks.